Relative velocity, type 3 vector triangles. So with type 3, sometimes we look at an object moving out in one direction and then coming back in the same direction. But in this one, we're just looking at one direction in the movement of an airplane. When we're doing these questions, we can either do them in the I and the J way, or we might be able to draw a nice big clear diagram, which makes it quite easy then to use our trigonometry and use the sine rule and the cosine rule. And of course, if you can't see this or can't draw these big clear diagrams, then of course just stick to the normal I and J way. So here we have an airplane that has a speed of 160 meters per second in still air. So what that means is that that's the velocity of the plane relative to the wind. Because when we're talking about relative, we're talking about if W is fixed, in other words, if the wind is fixed and not moving, well then what is the movement of P relative to that? So we always have to be careful with that when we're seeing in still air or still water, that's going to be the relative velocity. So that's 160 meters per second. The next thing that we're told then is that when the wind blows from the east, so it's coming from the east, then the velocity of the airplane as observed from the ground is 120 meters per second towards the northeast. So what this is then is that's the velocity of our plane, and that's 120 meters per second. So what we're trying to find then is the velocity of the wind. Okay, and we can't do VPW is equal to VP minus VW because, of course, we don't have these in terms of I and J. So just be careful that you're not using that formula on page 150 for our relative velocity. So we also have to note that the question is saying that we have to find the speed, okay, which is our magnitude, of course, and that's in terms of 2 decimal places. So if you're doing it in the I and the J way, you would have to get the magnitude of the velocity at the end correct to 2 decimal places. Okay, so how are we going to draw our diagram? Well, let's have a look at the information given to us. See, can you draw the diagram? Press pause in the video and then check, have you drawn it correctly? Okay, so we always want to start with our little mariner's compass to give us our direction for north, south, east and west. And I'm going to start with the velocity of the plane because we're told the velocity of the plane as observed from the ground is heading towards the northeast with the speed of 120 meters per second. So northeast is a very easy one to do because obviously northeast implies 45 degrees. So again, nice big diagram, and I'm marking in that angle there is 45 degrees, which of course means then put in the 45 first, which of course means that this is also 45. Okay, and that's the velocity of our plane. We're then told then that when the wind is blowing from the east, okay, so if I want to draw a diagram, I'm going to draw the wind so that it's hitting the airplane. So of course it's coming from the east, so it doesn't matter where I was to draw that arrow. But to complete a nice diagram and to draw a triangle, it's going to be easier to have heads to head there. Okay, so it's coming from the east. So that means we'll have our arrow coming in here. And that's the velocity of our wind, which is what we're trying to find. And then, of course, if we look at velocity of a plane, let me just write that in red actually. Velocity of the wind. So, of course, if I do velocity of plane relative to wind, what that means is that that's the velocity of the plane minus the velocity of the wind. So if I was to rearrange that, what I would have then is the velocity of the plane is equal to the velocity of the plane relative to the wind plus the velocity of the winds. So by completing my vector diagram, I know which way my arrows should be going because obviously it's head to tail, head to tail. So the velocity of the plane relative to the wind plus the velocity of the wind is equal to the velocity of the plane. So my vector diagram is going to come somewhere along here. And that would be the velocity of the plane relative to the wind. Do that in red. so that I'm joining head to tail for the velocity of the plane relative to the wind, and then plus the velocity of the wind, and then obviously the resultant then would be from start to finish there for the velocity of the plane. So you're always just kind of checking, have we set up our diagram correctly using your formula, which is on page 50 of your maths tables. Okay, so now we have our diagram drawn. Let's see what else can we mark in on it. Okay, so we know that the airplane was observed from the ground heading in a direction of northeast, which gave this angle here of 45 degrees from the ground. And of course then if the wind is coming from the east, that means then that is horizontal to the ground, which means then that we have these two angles are going to be equal. In other words, this angle here is going to be 45 degrees because, again, you have two horizontal lines and a transversal, which means that they are alternate angles. So they must be equal in size. So northeast, meaning 45 degrees, makes this angle up here, where the velocity of the plane and the velocity of the wind are meeting is 45. And because the wind is coming in from the east, that means that this must also be 90 degrees with our mariner's compass. So now we have an angle of 90 plus 45. If we want to find the velocity of the wind then, well, we have to see what else do we know. So if I take out this triangle and I make it into a clear triangle, well, what other information can I mark in it? Well, I can mark in the velocity of the plane relative to the wind is 160 meters per second. And we can say the velocity of the plane is 120 meters per second. So now you can see, well, we've got one angle of 135 degrees. We've got some velocity going on here. So therefore, if we want to find the velocity of the wind, well, that's one of our sides. Well, we're going to need another angle. And we can use the sine rule here. But of course, we need to see, well, what side is opposite 120? Well, it's this angle here. So let's call that alpha. And then I have the velocity of the plane and the angle opposite. So I have two sides and angles opposite, but I don't have the angle opposite the velocity of the wind. So we're going to have to use the sine rule twice to try and find this angle down here, which I'll call beta. Okay, so let's draw it out as a triangle now that we have our vector diagram drawn. Okay, so here you can see it a little bit clearer now that we have our sine rule. So if I call this side, let's call it, that's alpha. So let's call this side A, side B, and side C. And then we have our angle B, our angle A, and our alpha angle C. So if we're writing out our rule, we have A over sine A equals B over sine B. Or of course we can turn that upside down because we're looking for an angle here. So the first angle we're going to try and find is alpha. So I'm going to flip my formula there. So I'm going to say sine alpha over A, which is 120, equals sine B, which is 135 degrees, over the opposite side, which is 160. So sine alpha is equal to 120 times sine 135 over 160. And then if I get sine inverse of all of that, well, that gives me 32 degrees. Okay, so now of course I have alpha. Well, I can find what beta is. As we say, therefore beta must equal 180 minus 135 plus 32 degrees. So in other words, the angle beta is going to equal 13 degrees. So now what we can do is draw out our triangle again, so we can just fill in our information. Okay, so now we have all our angles filled in. You can see very simply that if I'm looking for the side C, it's opposite velocity of the wind, is opposite the angle 13, and I could take either of the other sides, 160 or 120. It doesn't matter. So I'm going to go with the 135 and the 160. So I'm going to say B over sine B is equal to C over sine C, based on what I've labelled my sides of my triangle as. And again, if I put in my sides then, well, I have the velocity of the wind is equal to, over sine 13 is equal to 160 over sine 135 degrees. So I've done C over sine C equals B over sine B there. So of course, to get that on its own then, I cross multiply. So I have 160 times sine 13 over sine 135, and corrected 2 decimal places then, that gives me 50.90 meters per second. And speed is what we were looking for. So in other words, it's just the magnitude. Okay, so let's have a look at the breakdown of marks for that then. So we had 10 for drawing a nice, clear, fully labelled diagram. We had 5 for setting up our sine rule, and 5 for getting our first angle out, and then 5 for getting our second angle out, and then 5 for getting our speed out. So we had 5, 10, 15, 20, 30 marks going for that question. Okay. And of course then, if we were looking at our diagram at the very start here, we had beta worked out to be 13 degrees. So of course, if we were looking at direction, if it was asking us for direction there, we'd have 45 plus 13, take it away from 90, would give us this angle here of 32 degrees. So therefore it would be going east 30 degrees north. So always be careful if they're asking for direction as well, which angle that you're going to write down. You're not going to take the angle of 13 degrees there as your direction. So nice question.